So hello everybody, first of all in this video, in this class we'll do the most important part, one of the most important part for a complex number, which is the geometry of the complex number. And nowadays there are a lot of papers, but
So hello everybody,
remember one thing,
in this video, in this class, we'll do the
but remember one thing, there are a lot of it means there are a lot of different papers, different questions are coming, but some particular places from which questions are coming, and this is that place which is a geometry of the complex number. And next few days we'll just go to the YouTube classes which are most important part and from which questions are surely coming, like 3-dimensional geometry, like this whatever we are starting, that is the geometry of the complex number. So first of all let us start solving the sum, then we'll discuss. Let us solve the PYQ previous. In this case nowadays this type of sums are coming, that some set is given and we have to just get the values. Okay, so here it is given that let's set A is equal to representing some z, z is a complex number, given that z minus I by z plus 2i belongs to real number. Then what is about the z? Let us solve, and if you can solve, my students, you must write this. Okay, so let us solve it. Here let z equal to x plus iy, given that z minus I by z plus I, z plus 2i belongs to R. It means this complex number is a real number, so its imaginary part is 0. So let us get its imaginary part and make it 0. Okay, so that should be our target. So we can write this as z minus I by z plus 2i equal to x plus iy minus I by x plus iy plus 2i. We have to rationalize the denominator, and if we just rationalize the denominator, we are getting, let us multiply numerator denominator by x minus I into y plus 2 total divided by x minus I into y plus 2. We are multiplying numerator denominator by this thing. So we are getting like this, x square minus 3xi plus y minus 1 into y plus 2. And moreover, one important thing we can see that just after 2019, from 2020, the sums are not only tricky, sums are calculative also. We have to prepare also for calculation. Okay, and all others, everyone, try to solve before me and send your answer. Denominator a plus b into a minus b, y plus 2 whole square. So we can see here what is the imaginary part, that is 3x by x square plus y plus 2 whole square equal to 0. So we can say x equal to 0. X equal to 0 means it is a straight line. X equal to 0 means we know it is a y-axis. Okay, so option D is the right option. Next sum. If z is a complex number such that z minus I by z minus 1 is purely imaginary, then you have to find the minimum value of this. And as we know that mod of z1 minus z2 is the distance between the 2 points. Complex number is a point on the ergot plane. Okay, so we have to get the distance from z to 3, 3. So how to solve this sum? Let us solve it. What to do here? Let z equal to x plus iy, and since purely imaginary, so its real part is 0. Whatever we have done in the previous, that purely real, its imaginary part is 0. Here purely imaginary, so we have to make the real part to be 0. Therefore we can write this as z minus I by z minus 1 equal to x plus iy minus I by x minus 1 plus iy. Once again, let us rationalize the denominator. If we rationalize the denominator, we are getting here only I am doing x minus 1 plus iy, it will be minus iy, total divided by x minus 1 minus iy. We are multiplying, we are getting just simply multiply, we are getting here what? X into x minus 1 plus y into y minus 1 plus I into something. It is not needed because it is purely imaginary. Our target is the real part should be 0. Okay. So whatever I into something not needed, because we have to solve the sum very fast in the entrance examination hall. Therefore, we can say that its real part is 0. So x into x minus 1 plus y into y minus 1 equal to 0. Therefore, x square plus y square minus x minus y equal to 0. It is a circle. So let us get the circle, center and radius. So x minus half whole square plus y minus half whole square equal to 1 by root 2 square. So this is the circle. This is the circle and whose center is half comma half and radius 1 by root 2. Therefore, we can write this as, this is a point, obviously is the point outside 3 comma 3 point. Our target is this z minus distance of any point satisfying the locus, it means on the circle, or to 3 comma 3 point. So since minimum distance, suppose this point is sum A, our target is AP and R we know, therefore minimum distance is equal to AP equal to coming to be OP minus OA. So we can write root over 3 square plus 3 square minus 1 by root 2 into 2. That is coming 3 root 2 minus root 2 equal to 2 root 2. Let us go to the next sum. If z and omega are two complex numbers such that mod of omega z, remember one thing, omega is like x. If it is given that it is a cube root of unity, then only we will apply omega as the cube root of unity, that values omega cube equal to 1. But in this case, omega means some complex number like z. Okay. So mod argument of z minus argument of omega equal to 3 pi by 2, we have to get this value. First of all, what you have to do, that z bar into omega we have to get separately. How to solve this sum? First of all, let us consider, let z equal to r1 into e to the power I theta and omega equal to r2 into e to the power I phi. So z bar is r1 e to the power minus I theta, we can say. E to the power I theta means cos theta plus I sin theta. If it is z, then z bar is cos theta minus I sin theta, that is e to the power minus I theta, like this concept. So we can write this as, given z into omega equal to 1, that is r1 into r2 into e to the power I, actually e to the power I anything, any angle equal to cos theta plus I sin theta. So this is the 1, its mod is 1. So we can say this is to be 1. So r1 r2 equal to 1. Given that argument of z minus argument of omega equal to 3 pi by 2. So it means theta minus argument means angle, theta minus phi equal to 3 pi by 2. First of all, we have to get this value z bar omega. How to get z bar omega? Let's see, r1 e to the power minus I theta into r2 e to the power I phi. This is z bar omega, which we are getting r1 into r2 into e to the power minus I theta minus phi. That is coming cos 3 pi by 2 minus I sin 3 pi by 2. Therefore, we can say z bar into omega equal to I. Now we have to get the argument value. The value of the argument is, so we can get argument of 1 minus this portion. This portion is important. We have to get the argument. Therefore, we can write this as argument of 1 minus 2 z bar omega by 1 plus 3 z bar omega equal to argument of 1 minus 2i by 1 plus 3i. So, this can be written as, once again we have to rationalize the denominator. So, if we rationalize the denominator, we are getting 1 minus 2i by 1 plus 3i, multiply numerator denominator by 1 minus 3i, 1 minus 3i. So, we are getting argument of a square minus b square, and if we calculate, we are getting minus 1 minus 8 and 4 is getting cancelled. So, minus half into 1 plus I. Argument of minus half plus 1 plus I, it means it is in the third quadrant, and for third quadrant we know argument in the third quadrant, because argument is the pointwise, argument in the third quadrant is theta minus pi. Theta means 1 plus I, that is pi by 4. Okay? So, in this case we are getting argument is minus pi plus theta, pi by 4. Okay? That is minus 3 pi by 4. So, here it is coming minus 3 pi by 4, here the extra value is written. Sum is over. Let us go to the next sum. Let C be the set of complex numbers and S1 set form. Nowadays, we are seeing that in 2021, 2022, questions are coming in the set form. So, we have to understand that exactly, it is very easy. We have to understand the set form. Okay? So, what to do? S1 is Z belongs to C, mod of Z minus 2 less than equal to 1. It is nothing but the circle, and set 2 is, let us see what is coming here. Anyone will tell anything? Let us go to the next. And everybody try before me. And I have selected the sums in such a way that we'll cover geometry part, whatever question coming, we can answer this JEE main examination, okay? Because this is very hot topic, this particular topic is there. So, let us solve this sum. Let Z equal to, we are seeing that here questions are not only tricky, what I told you previously, lengthy also, okay? So, we have to pick up some important part of the important subtopic of the mathematics, so that which are surely coming. Okay? So, I will give this type of classes. Next target should be 3D, 3-dimension geometry. So, let Z equal to x plus iy, we can write this as mod of Z minus 2 less than equal to 1. It means that x minus 2 whole square plus y square. Z is any point x comma y, its distance from 2 comma 0 less than equal to 1. It means it is the point represent, this set represent all the circles, all the points on the circle or inside the circle, okay? This which is less than equal to 1. Now, suppose we are giving this as number 1. Also we can say here that z into 1 plus I plus z bar into 1 minus I greater than equal to 4, which is given. what to be done? Let us write z equal to x plus iy, z equal to x plus iy into 1 plus I plus x minus iy into 1 minus I greater than equal to 4. Okay. So, if we write just in this case, what we have to take, that if we cancel here, this x is there, so 2x, and if we take the I square, it means y minus 2y greater than equal to 4, all other are getting cancelled, so y less than equal to x minus 2. So, 1 is the circle and 1 is the line. Now, how to proceed? Let us draw. This is a circle whose center is 2, 0 and radius is 1. And this is the line y equal to x minus 2, and we need the point which is satisfying S1 intersection S2, means all points satisfying both the set. It means common to the circle and the straight line. So, y equal to mx plus c, y equal to x minus 2. If we put x equal to 0, y equal to minus 2. If we put y equal to 0, x equal to 2, and 2 is the center. So, it means it is passing through the center. This line is passing through the center. Suppose this is a point P and this is the point Q, and this is the center 2, 0, and our target is what? That maximum distance of z, z means this satisfactory points on P and Q from 5, 2. It means everybody, this is the point 5, 2. This is the 5, radius is 1, so 2, 1, 3, this is 3, 0. So, this is the 5, 2. 5, 2 means the maximum distance, means suppose this point is T point. So, Q is that point, not P. Z representing the Q, because maximum distance. If it would have been the minimum distance, then it would be P. Okay? Exactly, we need TQ point. So, first of all, we have to solve the line and the line and the circle. If we solve line and the circle, we are getting what? X minus 2 whole square and y equal to x minus 2, if we put plus x minus 2 whole square equal to 1. Therefore, 2 into x minus 2 whole square equal to 1, x equal to 2 plus minus 1 by root 2. Okay? But our target is the Q point. Q point is what, everybody? Q point is 2 minus 1 by root 2, and if we put 2 minus 1 by root 2 in the equation y equal to x minus 2, we are getting y is coming what? Minus 1 by root 2, and target is this is the target. Target is this is the maximum value, and it would have been minimum, then PT would be the minimum value. Okay? So, let us get the maximum value of here. We are getting mod of z minus 5 by 2 at Q point. Okay? So, we are getting here that 2 minus 1 by root 2 minus I by root 2 minus 5 by 2. This distance is our target, that is minus half minus 1 by root 2 minus 1 by root 2 mod whole square. So, everybody get the result and distance. These are the mod. So, get the result and distance formula, and we are getting the result. This is I. And according to the question, we are seeing that answer will be 5 plus, you calculate and see 5 plus 2 root 2 by 4. It means answer is this. I am not calculating further. Okay, let us go to the next one. The area of the triangle with the vertices A, B and C. Here we can see in this sum two complex numbers A and B. And what is Z? Z means suppose x comma y point. So we can write this as, if we draw the structure, we are seeing that we know that Iz by Z equal to I, that is e to the power I pi by 2. It means when Z is rotated to Iz, it is 90 degree, okay, 90 degree rotation. Suppose this is a Z point, so this is the Iz. So we need the, and the resultant is Z plus Iz. Therefore, we need the this angle is the 90 degree. So for any triangle, and this is a repeated sum of the JEE, for any triangle, area half base into altitude, so half Z into Iz, that is half Z square. So first option is the answer here. Let us go to the next sum. Let a complex number W equal to 1 minus I root 3. Let another complex number Z be such that mod of ZW equal to 1 and argument of Z minus W equal to pi by 2. Then to find the area of the triangle with the vertices origin Z and W. How to solve this sum? Let's see everything. In this case, the complex number W is, we have to make it to the omega. We are seeing that it is like omega. Okay? So we have to make it omega. What can be written? 1 minus 1 minus I root 3 by 2 is omega. So this is coming 2 into e to the power I pi by 3 form. That is coming 2 omega. And therefore, here we are getting mod ZW equal to 1, mod of W equal to 2, therefore mod of Z equal to half. So let Z, we can write this as half into e to the power I theta. We can write, now it is given that argument of Z minus argument of W equal to pi by 2. So we can write theta minus pi by 3 equal to pi by 2. Therefore, theta equal to 2 pi by 3. So one is pi by 3, one is 2 pi by 3. So angle between them. So one is 60, one is 120. So angle between them. Okay. So what can be written? Therefore, area is half base. Actually, it is omega square. Theta is, Z can be written as half omega square, which is the cube root of unity. So omega square into 2 omega. So we are getting to be half as omega cube equal to 1. Okay. So let us go to the next sum. Yes. Yes, right. Yes, Pratyay. Go to the next sum. Let the lines, these to be the normal to the circle. If the line Iz plus Z bar plus 1 plus I equal to 0 is a tangent to the circle, then its radius. Do it first. Try to solve this sum. Next. Next everyone, do this, activate. Let z equal to, in this case what to be done? Let z equal to x plus iy and z bar equal to x minus iy. So first of all, we'll get these two lines first. So what to be done here? 2 minus I into z, z means x plus iy equal to 2 plus I into x minus iy. If we calculate, we are getting 2x plus I 2y minus ix plus y equal to 2x minus 2iy plus ix plus y, that is 2y equal to x. One line we got one line. Let us go to the another line. Also we can say 2 plus I into z plus I minus 2 into z bar minus 4i equal to 0. So again we can write this as 2 plus I into z x plus iy plus I into y, not I, it is coming what? I minus 2. I minus 2 x minus iy minus 4i equal to 0. So everybody, whatever we are seeing, that this is geometry of the complex number is coming in every paper, but lengthy also. You have to calculate, you have to practice continuously the calculation portion also, not only the sums. Okay. So we are seeing here, if we multiply, we are getting 2x plus I 2y plus ix minus y plus ix plus minus 2x plus y plus I 2y minus 4i equal to 0. So x plus ix they are cancelled, x plus 2y minus 2 equal to 0. This is the number 2. Solving 1 and 2, if we solve 1 and 2, instead of x, if we put 2y, so what we are getting? 4y equal to 2, y equal to half. If y is half, x is 1. So solving 1 and 2, from 1 and 2, we are getting x equal to 1 and y equal to half. Okay. Once again, let us get the tangent. So equation of the tangent is what? Iz plus z bar plus 1 plus I. This question came in 2021 February. So let us write this. Iz plus z bar plus 1 plus I equal to 0. I into x plus iy plus x minus iy plus 1 plus I equal to 0. Therefore, ix minus y plus x minus iy plus 1 plus I equal to 0. So if we calculate this, we are getting x minus y plus 1 equal to 0. Now we got a circle. We got a circle whose tangent is this, whose center is 1, comma okay, everybody, who can tell it? Who can write this? 1 comma half, and tangent is x minus y plus 1 equal to 0. So if we put this, we are getting radius r equal to 1 minus half, perpendicular distance from the center, by root over 1 square plus 1 square. We are getting here 3 by 2 root 2. Let's go to the next sum. If z1 and z2 are complex numbers such that real z1 means complex number has two parts. One is the real part, one is the imaginary part. Real z1 means x, z is x, and imaginary z means y. So real z1 equal to mod of z minus 1 and real z2 equal to mod of z2 minus 1 and argument of z1 plus z2 equal to pi by 6. Then we have to find the imaginary of z1 plus z2. How to solve this sum? Let z equal to, suppose z1 equal to x1 plus I by 1, z2 equal to x2 plus I by 2. Therefore, we can write this as, according to the question, real z1, it means x1, I am writing z1 equal to x1 plus I by 1 and z2 equal to x2 plus I by 2. Therefore, we can write this as x1, according to the question, real z1 equal to mod of z1 minus 1. Mod of z1 means x1 plus I by 1 minus 1. So, x1 minus 1 plus I by 1. It means if we do the mod, we are getting here x1 minus 1 whole square plus y1 square. Similarly, like for the second portion, real z2. So, we are writing this x1 minus 1 whole square root over plus y1 square. I am writing this as x1 square. Okay. So, again if we open this, let us open this, x1 square minus 2x plus y1 square equal to x1 square. So, we can write this as 2x1 equal to y1 square plus 1. Similarly for real z2, for real z2 equal to mod of z2 minus 1, we can write same thing. We can write this as what? 2x2 equal to y2 square plus 1. So, let us subtract these two. Let us minus these two. We are getting 2 into x1 minus x2 equal to y1 square minus y2 square. It means y1 minus y2 into y1 plus y2. Therefore, y1 plus y2 equal to 2 into x1 minus x2 by y1 minus y2. Therefore, we can write this as y1 minus y2 by x1 minus x2 equal to 2 by y1 plus y2. Now, we are given that argument of z1 plus z2, argument of z1 plus z, actually it will be minus, argument of z1 minus z2 equal to pi by 6. So, argument of z1 minus z2 means tan inverse y1 minus y2 by x1 minus x2 equal to pi by 6. Therefore, y1 minus y2 by x1 minus x2 means 2 by y1 plus y2. From here we are seeing, okay. Therefore, this is coming to be 2 by y1 plus y2 equal to tan pi by 6, so 1 by root 3. So, 1 by root 3. Therefore, y1 plus y2 equal to 2 root 3. So, what is y1 plus y2? It is the imaginary part of z1 plus z2, because z1 is x1 plus I by 1, z2 is x2 plus I by 2. Therefore, it is the imaginary part. Therefore, imaginary z1 plus z2 equal to 2 root 3. So, students, not only the concept, we need the practice at the last moment also. We have to practice the sums so that we can have the calculation ability. This is only, there is no tricks and nothing everyone, just only the practice which does the matter. Let us go to the next sum. Let us come to the next sum. If the 4 complex numbers z, z bar minus 2 into real z bar, z minus 2 into real z represent the vertices of a square of sides 4 unit, then find mod z. How to solve this sum? Same as this, let z equal to x comma y, that is x plus I y. So, let us drop one. Suppose this is A, Z, B, Z bar, C, Z bar minus 2 real Z bar, and D point is the last point, Z minus 2 real Z. Length of the side is 4. Here suppose AB equal to 4, that is Z minus Z bar, distance between 2 points, Z1 minus Z2, mod of Z1 minus Z2. So Z minus Z bar equal to 4. Z minus Z bar, Z is x plus Iy, Z bar is x minus Iy. So x portion is cancelled. So 2Iy, mod of 2Iy equal to 4. That is coming mod y equal to 2. Also, we can see BC equal to also 4. BC means Z minus mod of Z minus Z bar minus 2 real Z bar equal to 4. That is 2x Z bar is getting cancelled, and this is coming 2x equal to 4. So mod of x equal to 2. So our target is mod z. Mod z is root over x square plus y square. That is coming root 8. That is 2 root 2 is the answer. Let's go to the next sum. This is one sum. Z equal to 1 minus I root 3 by 2. We know that cube root of unity is minus half plus I root 3 by 2 and minus half minus I root 3 by 2. And this type of sum, if we can solve in terms of omega cube root of unity, it will be better for us to calculation. So let us come to this. What to do? What will be the answer here? Z equal to 1 minus I root 3 by 2. If we provide minus here, so minus of minus 1 plus I root 3 by 2, that is coming minus omega. And we know that 1 plus omega square, here omega is the cube root of unity. Now 1 by 1 part we have to write up. There are 21 plus, there are z, z square, z cube, there are 21 such cubic factors. So let us get some similarity which is coming here. So let us start everybody. So z plus 1 by z, we are getting minus omega minus 1 by omega. 1 by omega means if we multiply here minus 1 minus omega square by omega cube, that is minus 1 minus omega square, that is coming to be 1. In this way, very fast calculation we have to proceed. So next, z square plus 1 by z square, we are getting omega square plus 1 by omega square, that is coming omega square plus 1, that is coming minus 1. Z cube plus 1 by z cube equal to, what we are getting? Minus omega cube minus omega 1 by omega cube, that is coming minus 2. Now z to the power 4 plus 1 by z to the power 4, we are getting here 1 by z to the power 4, we are getting here omega to the power 4, that is omega plus 1 by omega, that is coming minus 1. Z to the power 5 plus 1 by z to the power 5, which is coming to be minus omega to the power 5, that is omega square, omega cube actually 1, and minus 1 by omega to the power 5. So we are getting minus of omega square plus 1 by omega square, that is coming 1. Z to the power 6 plus 1 by z to the power 6, whatever we are getting here, that is 2, okay? And in this case, z to the power 7 plus 1 by z to the power 7, we are getting minus omega to the power 7 minus omega to the power 7. We are getting minus omega minus 1 by omega. So it is being repeated again. At 7 it is being repeated. So up to 6, the different values are coming from 7, it is being repeated. 6, 12, 18, they are getting repeated. And 19, 20, 21, let us write some different. It means we can write this as final value is coming 21 and up to 6, these are the different values which you are getting. 21 plus 1 minus 1 minus 8 minus 1 plus 1 plus 8 into 3 plus 1, 19 is 1, 20 is minus 1, 20 is minus 8. Therefore, ready, what is coming here? 21 minus 8 equal to 13. 13 is the answer. Okay, let us go to the next one. Let Z1 and Z2 be two complex numbers such that argument of Z1 minus Z2 equal to pi by 4 and Z1 Z2 satisfy the equation mod of Z minus 3 equal to real Z, then imaginary part of Z1 plus Z2. What to do? Imaginary part of Z1 plus Z2 means Y1 plus Y2. What to do? Let same as previous case x1 plus iy1 and z2 equal to x2 plus iy2. Now z1 minus z2 equal to x1 minus x2 plus I into y1 minus y2. So same as this previous case, everybody, we can write this here, z1 minus z2 and argument of z1 minus z2 equal to pi by 4 and satisfy the equation mod of z minus 3 equal to real z. So what can be written? We can write argument of z1 minus z2 equal to pi by 4. Therefore, y1 minus y2 tan inverse y by x, x1 minus x2 equal to 1. So we can say y1 minus y2 equal to x1 minus x2. So this is coming number 1. Okay. Given that mod of z1 minus 3 equal to real, they are satisfying mod of z minus 3 equal to real z. There are two z, z1 and z2. So we can write mod of z1 minus 3 equal to real z1. So we can write here x1 minus in this case what is coming here, mod of z minus 3, so we got already mod of z minus 3 equal to real z. It means what? Z1 minus 3 here, that is x minus 3 whole square plus y square equal to z. Z means x, real z means x. So we can write this as x1 minus 3 whole square plus y1 square equal to x1 square. Mod, I am removing the mod sign, so root over sign. Similarly, mod of z2 minus 3 is coming x2 minus 3 whole square plus y2 square equal to x2 square. If we subtract these two, we are getting here x1, a square minus b square, x1 minus 3 whole square minus x2 minus 3 whole square plus y1 square minus y1 square minus y2 square equal to y1 equal to coming x1 square minus x2 square. It is a square minus b square formula. We are getting x1 minus x2 into x1 plus x2 minus 6 plus y1 minus y2 into y1 plus y2 equal to x1 minus x2 into x1 plus x2. Now instead of y1 x1 minus x2, if we put y1 minus y2, we are getting here x1 plus x2 minus of minus 6 and plus y1 plus y2. We are getting cancelled. Okay, so x1 plus x2 portion. So we are getting x1 plus x2, x1 minus x2 portion. So y1 plus y2 equal to 6. Therefore, which is the imaginary part of z? Therefore, imaginary z1 plus z2 was there. Z1 plus z2 equal to 6. So everybody, sums are coming lengthy nowadays. Be ready for that. Next. A point Z moves in complex plane such that argument of Z minus 2 by argument of Z plus 2 equal to pi by 4. Find the minimum value. Actually, argument of Z minus 2 by argument of Z plus 2 equal to alpha, it represents some part, bigger part of the circle, okay, from minus 2 to plus 2, but this concept will apply in JEE advanced preparation, not now. Just let us apply simple way for solving the sums for JEE main. For JEE advanced, we will do separately complex number, because for JEE advanced also this is very important chapter, this geometry of the complex number. So that time we will apply that circle concept, it will be more easier for us. But in JEE main, so much is not needed. So let us proceed. First of all, we can write here argument of Z minus 2 by, actually argument of Z minus A by Z plus A representing equal to alpha, alpha lying between 0 to pi by 2 represent greater part of the circle, okay, but we will do this later. Let us apply with the JEE main type sum, since it is a JEE main question paper, we are solving for JEE main. So equal to pi by 4. So what can be done here? Z equal to x plus iy, argument of x plus iy minus 2 by x plus iy plus 2 equal to pi by 4. Therefore, if we just apply like this, x minus 2 plus iy into let us rationalize the denominator. Let us rationalize the denominator. Minus iy equal to pi by 4. So if we rationalize the denominator, we are getting already denominator is coming x plus 2 whole square plus y square, and numerator what is coming? X minus 2 into x plus 2, x square minus 4, x square minus 4, and plus iy minus iy, it means plus y square. And for y portion, they are getting cancelled, I part is getting cancelled, we are getting plus I 4y. Everybody calculation fast. We have to calculate fast to get the good result in mathematics, because after 2019 questions are coming long, lengthy questions in mathematics. Okay. So let us proceed with this. Equal to pi by 4. Therefore, it is coming tan inverse y by x, that is 4y by x square plus y square minus 4 equal to pi by 4. Tan inverse y by x equal to 1. So we are getting here, if we cross multiply, tan pi by 4 is 1. We are getting x square plus y square, x square plus y square minus 4y plus 4 equal to 8. That is x minus 0 whole square plus y minus 2 whole square equal to 2 root 2 whole square, which represent the circle. This calculation we could get easier also by circle, by drawing the circle. Okay, that trick will go for the next class, that is after JEE main class on complex number. Now this is the circle, and this circle, this is 0, 2, radius is 2 root 2, and this is the point. Obviously, this point is the 9 root 2, 2, obviously outside, 9 root 2, 2, this is outside. Okay. So we have to get the distance, minimum distance. It means the point should be here, this distance is needed. The point should be here, this point should be A, suppose. So to get the minimum distance, we are getting mod of z minus 9 root 2 comma 2 whole square equal to, actually if we give this as the C, so we are getting the circle, suppose center is C, we are getting Cp minus R whole square. That is, if we calculate, we are getting, if we calculate, we are getting here 9 root 2 minus 0 whole square plus 2 minus 2, 2 minus 2 whole square minus 2 root 2 minus 2 root 2 whole square. It means we are getting here 7 root 2 whole square. 7 square 49 into 2, that is coming to be 98. So here it is coming to be 98. Numerical type question it was. Let's go to the next one. The equation of the circle is real z square, z equal to x plus iy. So z square is x plus iy whole square, that is x square minus y square plus 2ixy. So real z square is x square minus y square. In this way we have to think an imaginary z square plus 2 real z equal to 0, where z equal to x plus iy, a line passing through the center of the given circle. Okay, it is a circle, center of the given circle, and the vertex of the parabola this. If we have to find its y-intercept, what can be done? So whatever I told you, that real z square means x square minus y square. So x square minus y square plus 2y square plus 2x equal to 0. Therefore x square plus y square plus 2x equal to 0. Therefore the center of the circle is minus 1 comma 0. Also this is a parabola, x square minus 6x minus y plus 13. So here one is the square and one is the single, x portion is square. It means the parabola axis is parallel to the y axis. In this way we have to practice. We have to practice so much, not very hard. Question is not very hard, but the concept you have to make it clear. Okay. So we are getting here, absorb all the x to make a whole square. We are getting x minus 3 whole square. If we take 3 as plus 9, so balance by minus 9 minus y plus 13 equal to 0. So we are getting x minus 3 whole square. In the right hand side, if we take it, we are getting what? Y minus 4. Therefore vertex is coming 3 comma 4. Therefore equation of the line passing through, it means equation of the line passing through minus 1 comma 0 and 3 comma 4 is what? Y minus y1 or y equal to, as you think better, y minus y1 equal to m into x minus x1. So y equal to 4 by 4 into x plus 1. So y minus x equal to 1. Therefore y-intercept equal to 1. Okay, let's go to the next one. Let z and omega be two complex numbers such that omega or w, whatever you think, is z bar minus 2z plus 2, and given that mod of z plus I into mod of z minus 3i equal to 1, real omega has the minimum value of n, for which omega to the power n is the real number. How to solve this sum? We are given that mod of z plus I by z minus 3i equal to 1. So, mod of z plus I equal to mod of z minus 3i. So, remember one thing, this is distance of z, z means x comma y, it means the locus is like this, we can think like this, x to 0 comma minus 1, distance of any x y, that is z, to 0 to minus 1 equal to distance of any x comma y to 0 comma 3. It means locus of z is the perpendicular bisector of the line segment joining 0 minus 1 and 0 3. So, zero minus 1 and 0 3, its perpendicular bisector is this thing. So, this is coming y equal to 1, locus of the z is y equal to 1. So, let us pick up any point. Let us pick up any point, let z equal to x plus I. X is anything, but y is I. Y equal to 1, y is I, 1i. So, in this case, we can write this as omega. This is not cube root of unity, mind it. Omega equal to, given that z bar, it means x plus I into x minus I minus 2 into x plus I plus 2. So, we are getting here x square plus 3 minus 2x minus 2y, that is, we can write x minus, absorb all the x omega whole square, x minus 1 whole square plus 2 minus 2y. Real omega is minimum when x equal to 1. So, we can write this as x equal to 1. Since x equal to 1, therefore, omega equal to 2 minus 2y, that is 2 root 2 into e to the power minus I pi by 4. Okay. So, we can write omega to the power n equal to 2 root 2 whole to the power n into e to the power minus I n pi by 4. We are seeing that least value of n for which omega to the power n is real, we have to make it n equal to 4. If we make n equal to 4, it will be coming e to the power minus I pi, that is cos pi minus I sin pi portion is 0, I part is 0, so it is coming real. Therefore, n equal to 4, sum is over. So, here it is coming to be 4. Let us go to the next sum. Let us go to the next sum. The least positive integer n such that 2y whole to the power n by 1 minus I whole to the power n minus 2 is a positive integer. Numerical type question. So, what can be done? This type of sums we have to do very fast. So, 2I whole to the power n by 1 minus I whole to the power n minus 2 equal to 2 to the power n I by 1 minus I whole to the power n into 1 minus I whole square. 1 minus I whole square means 1 plus I square, that is 0 minus 2I. So, we are getting here 2 to the power n, because we have to calculate very fast, not only that we have to solve step by step. Something you have to calculate orally and something sometimes you have to calculate by writing. So, we are getting here I into, 1 minute, we can write this here 2 to the power n, if we rationalize I into 1 plus I total divided by 1 minus I square whole to the power n into minus 2I. Okay. So, minus 2I because 1 minus I whole square, 1 plus 1 minus 1 minus 2I, that is why minus 2I. So, if we write this is coming 2 to the power n, outside is coming 2 to the power n minus 1 plus I whole to the power n into minus 2I. So, we can write this as 2 into minus I into root 2 if we multiply e to the power I, okay, 3 pi by 2, so 3 pi by 4 whole to the power n, and minus I means e to the power minus I pi by 2, because I equal to 0 plus I, similarly minus I equal to 0 minus I. So, e to the power minus I pi by 2, and if we calculate, we are getting directly 2 to the power n by 2 plus 1 into e to the power I into 3 n pi by 4 minus pi by 2, because I minus I. Now we can write this as it is to be positive integer. It is to be positive integer. Therefore, what to be done? 3 n pi by 4 minus pi by 2 equal to 2k pi, where k belongs to integer number. So, 3 n, what is coming here? 3 n by 4 equal to 2k plus half, where n equal to 2/3 4k plus 1 form. 2/3 4k plus 1 form. Now what you have to do? We have to get different values of k, for which we are getting the least values, least positive integer. Let's see, for every k less than 0, we are getting n less than 0. ABSir will not take this, ABSir case. If we take k equal to 0, for every k equal to 0, we are getting n equal to 2/3. It is also not acceptable value. If we put k equal to 1, for every k equal to 1, we are getting what? N equal to 10 by 3, not accepted. If we put k equal, there is no any another way. We have to put the values of k and to get the result. K equal to 2, we are getting n equal to 2/3 into 9, that is coming 6, which is the acceptable value. So, least value of n is 6. Sum is over. Let's go to the next sum. If the real part of the complex number z equal to 3 plus 2i cos theta by 1 minus 3i cos theta is 0, then the value of sin square 3 theta plus cos square theta. What to do? If the real part of the complex number is 0, so let us do one thing. Let us get the real part. So let us rationalize the numerator denominator. So 3 plus 2y cos theta total divided by 1 minus 3i cos theta into 1 plus 3i cos theta by 1 plus 3i cos theta. Let us rationalize the denominator. So we are getting here z equal to 3 minus 6 cos square theta plus I, what is coming? 1 plus cos theta total. Our target is real part. 1 plus 9 cos square theta. We have to calculate very fast. Unnecessary thing is not needed. Our target is real part is 0, imaginary part is not important here. Okay. So we can write this as real z equal to 0, given real z equal to 0. Since real z equal to 0, we can write this as 3 minus 6 cos square theta equal to 0. So cos square theta equal to half. So cos theta, theta equal to 45 degree we can write. So therefore we can write this as sin square 3 theta plus cos square theta equal to sin square 135 degree. plus cos square 45 degree is coming 1 sin 1 35 degree, that is 1 by root 2. So answer is coming to be 1. Let us go to the next sum. The value, this type of values which are given, we have to get it into some omega part. In omega or in I, it will be easier for us, because one denominator, if we see, it is given 1 minus I whole to the power 24, 1 plus I whole to the power 24. Okay, what happened to all others? Solve the sum and write the answer. So 1 plus I whole square means what? 1 plus, something we have to keep in mind, 1 plus I whole square, 1 minus I whole square, all these things, some omega cube root of unity calculation, this we have to keep in mind what we have done. Okay, so 1 plus I whole square means what? 2i. 1 minus I whole square means what? Minus 2i. Omega value minus 1 plus I root 3 by 2. Omega square minus 1 minus I root. All there are something which you have to keep in mind. Therefore, we can write this as, let us solve this. We have to express this in terms of omega. So, okay, I am writing here omega equal to minus 1 plus I root 3 by 2. And omega square we know, minus 1 minus, we have to express in terms of all this by 2. So, and 1 plus I whole square equal to 2i and 1 minus I whole square, because we have no time, and in the entrance examination hall you have to answer very fast, very prompt, and we are seeing that questions are not coming harder. These questions are not tricky, not very much tricky, not harder, but problem is that the questions are lengthy. So we have to solve the sum, we have to practice in our home in such a way that we can solve the sum very, very fast. Okay, and for this we need to practice lot of papers which has been given to us, given to you. We have to practice so much paper so that you can solve all this question very fast. Okay, so must solve all the papers which has been given. Now k equal to, I am writing, suppose k is this, minus 1 plus I root 3 whole to the power 21 by 1 minus I whole to the power 24 plus 1 plus I root 3 whole to the power 21 by 1 plus I whole to the power 24. This is I have written, not required to write in the examination hall. In the examination hall, just only to answer, so that you can understand. That is why I have written very short. I am writing this. This is coming to be 2 omega whole to the power 21 by minus 2i whole to the power 20 whole to the power what? 12, because 1 minus I whole square, that is minus 2i whole to the power 12, and here we can write this as minus 2 omega square whole to the power 21 total divided by 2i whole to the power 12. Now let us calculate. Just calculate here. We are getting 2 to the power 21 omega to the power 21 2 to the power 12 I to the power 12 minus 2 to the power 21 omega to the power 42, that is the omega cube product, 2 to the power 12 I to the power 12. This is coming to be 0. So n equal to mod of box of mod k, that is coming 0, n equal to 0 is coming. Now we are putting the value, n equal to 0 is coming. Now we are putting the value. Now summation of j equal to 0 to n plus 5 n to 0. So 0 to 5 we are getting j square. Directly I am writing this, n equal to 0. So 0 to 5 we are getting j plus 5 whole square, that is j square plus 25 plus 10j, and this is coming minus j minus 5, minus j minus 5. Okay, so this is coming summation of j equal to 0 to 5, that is j square, plus 9 summation of j equal to 0 to 5, that is j, plus 20 summation of j equal to 0 to 5, 1. So, we are getting here 0 square plus 1 square plus 2 square. This is AP formula, AP summation formula. Directly I am putting the value 5 into 6 into 11 by 6 plus 9 into 5 into 6 by 2 plus 20 into this is 6. So, here it is coming 55 plus 135 plus 120. 122, 200, 55 plus 35 is 60 plus 39, 20. It means 310 is the right answer. And this particular chapter which we are doing, geometry of the complex number, is very, very important. One of the most important topic for the entrance examination. So, must solve all the papers which has been given, and after the class also I will give one paper. Next, the sum of the 162th power of the root of the equation x cube minus cubic equation. Only one way we have to apply the heat and trial method. What can be done here? If we put x equal to 1, we are seeing only heat and trial method is important for JEE main, but for JEE advanced there are some rules for finding the cubic equation that I will tell. I will take the class later. So, let us calculate. X equal to 1 is satisfying. So, let us make the factor of x minus 1. So, if we make the factor of x minus 1, we are seeing x cube minus x square minus x square. I am writing this expression as plus x, because to that vanishing method or heat and trial method or trial and error method, whatever you say, like this, only cubic equation we can solve by this. There is some another method also for solving the cubic equation, but not needed for JEE main examination. For JEE advanced ISI we will discuss later. So, if we just take x minus 1, extract x minus 1, we are getting here x square minus x plus 1. So, either x equal to 1 and x square minus x plus 1 equal to 0. So, in this case x square minus x plus 1 equal to 0. We know that we have to remember this 1 plus x square equal to 0. It means x equal to omega and omega square. Then 1 minus x plus x square. So, x equal to minus omega square. So, sum of the 160, okay, I am writing. Sum of 162th power of roots equal to 1 to the power 162 minus omega square to the power 162 minus omega to the power 162. So, we are getting what? 1 plus omega to the power 162 into 2 is what? 324 plus omega to the power 162. So, we are getting 1 plus omega cube whole to the power 108, that is 1. 1 plus omega cube whole to the power 54. It means this also 1. Answer is coming 3. Let us go to the next sum. If 1 plus I by 1 minus I whole to the power m by 2 equal to 1 plus I by I minus 1 whole to the power n by 3. So, while solving any sum in entrance examination paper, they will always give some twisting sums. Totally first read in details, do not be confused. Sum is not hard, but we are seeing that there are some calculations in the sum. Okay? So, let us proceed for this. What should be the answer of this? What should be the answer of this question? Let us proceed. So, we can write this as 1 plus I by 1 minus I whole to the power m by 2 equal to 1 plus I by I minus 1 whole to the power n by 3 equal to 1 is given. So we can write, let us rationalize the denominator as previous, 1 plus I whole square by 2 whole to the power m by 2. Similarly, 1 plus I whole square by minus 2 whole to the power n by 3 equal to coming 1. Therefore, I to the power 1 plus I whole square means 2i. I to the power m by 2 equal to minus I whole to the power n by 3 equal to 1 means I to the power 4. Therefore, we can write this as m by 2. We have to take the least power. M by 2 equal to 4. N by 3 equal to 4. Actually 4k1. So, since least power is needed, so unnecessary. M equal to product of 8. Okay, I am writing this as the k1. This is k2. So much is not needed. 8k1 and n equal to 12k2. So, least value GCD. GCD means HCF is GCD of 8 and 12. Answer is coming 4. Let us do one more sum. (2022) June. Let circle C pass through the point Z1 equal to 3 plus 4y, Z2 equal to 4 plus 3i, Z3 equal to 5 plus I. If Z is a point on the C such that the line through Z and Z1 is perpendicular to the line through Z2 and Z3, find the argument of Z. So, in this case we are seeing 3, 4, 5. It means Z1, Z2, Z3 are the points on the circle x square plus y square equal to 25. In this way we have to practice. Okay. Therefore, we can write in this way. Then what can be done? Let us draw the circle. This is a point 3, 4 and 4, 3. Okay. So, suppose this point is, this is a point, P is some Z, P is some Z, Q is the 4, 3. A is the point, suppose 3, 4. 3, 4, and suppose R is the point 0, 5i means 0, 5. Okay. So, if we joined RQ, suppose this is a Q point. If we joined RQ and this is the PA, they lying on the circle x square. They lying on the circle x square plus y square equal to 25. Okay. So, slope of QR equal to y2 minus y1 by x2 minus x1 equal to minus half. So, slope of AP equal to 2. Then equation of AP is y minus y1 equal to m into x minus x1, that is y equal to 2x minus 2. P lies on the circle x square plus y square equal to 25. So, P is x comma y point. Therefore, we can write this as x square plus 4 into, if we put the point y value y equal to 2x minus 2, so 4 into x minus 1 whole square equal to 25. Okay. Then let us calculate x square plus 4x square, that is 5x square minus 8x minus 21 equal to 0. Therefore, let us go to the middle term factorization, minus 15x plus 7x minus 21 equal to 0. So, x minus 3 into x minus, this is coming 5x, if we take common 5x plus 7 equal to 0. X equal to 3 is not possible because already one point is there A. X equal to 3 is not possible. Therefore, we can say x equal to minus 7 by 5. If x is minus 7 by 5, so y is what? Put in the straight line equation. Y is what? Y equal to minus 24 by 5. And argument of z, since z is in the third quadrant, so argument of z is theta minus phi. Therefore, argument of z equal to tan inverse 24 by 7 minus phi, since it is in the third quadrant. So, the answer option is coming what? Minus pi. Let us do the next sum. Let Z1 and Z2 be two complex number where Z1 bar equal to I Z2 bar, and argument of Z1 by Z2 bar equal to pi. Then we have to get the result. This type of geometrical sum, this type of sums we can solve by geometry also, or we can solve by straight way also. So, let us apply this. All these type of sums which can be solved in short way in geometry in drawing the structure, but better for JEE main purpose, let us apply the straight method. In this case, Z1 bar equal to I Z2 bar. So, if we take the bar on the both side, and if we take the conjugate on the both side, we are getting Z1 equal to minus I, because conjugate of I is minus I. These are very important short tips, must remember. We are taking conjugate on the both sides. So, conjugate of conjugate Z1 is Z1, conjugate of I is minus I, conjugate of Z2 is Z2. And we are given that argument of Z1 by Z2 bar equal to pi. So, let us put the value instead of Z1, that is Z2, that is argument of minus I Z2 by Z2 bar equal to pi. So, if we calculate, let argument of Z2 equal to theta. If it is, let us calculate. So, minus pi, because minus pi by 2, because argument of minus I is minus pi by 2. Minus I means 0 comma minus 1, this point 0 comma minus 1, this is minus pi by 2, that is why minus pi by 2, and plus theta equal to pi. So, 2 theta equal to 3 pi by 2. So, argument of Z2 equal to theta equal to 3 pi by 4. And what is the target? Argument of Z1 equal to pi by 4. Let us go to the next sum. There are some sums which is very fast we can solve, not so much calculation, and there are some sums which are the calculative. Okay, and as you know that the mathematics is the determining factor, so you have to practice tremendous on calculation as well as obviously concept does the matter. Let us go to the next sum. 26th June, shift 1, 2022. Let A be the set containing the complex number that mod of z minus 1, mod of z plus 1 by mod of z minus 1 less than 1, and B be the another set where argument of z minus 1 by z plus 1 equal to 2 pi by 3, then A intersection B. We have to get A intersection B. মানে common z, common points, common locus of A and B, two sets. How to solve this sum? Let us see. First of all, mod of z plus 1 by mod of z minus 1 equal to less than 1. Therefore, mod of z plus 1 less than mod of z minus 1. Okay, so x plus, we can write this as x plus 1 whole square plus y square mod of z plus 1 x minus 1 plus iy, its mod. So that is why x plus 1 whole square plus y square. Mod of z minus 1 is x minus 1 plus iy. So we can write this as, which is less than x minus 1 whole square plus y square. So x less than 0. It means the shaded area is in the this side. This is the set, all the points satisfying. All the points satisfying. Suppose this is 1 comma 0. It's not there in the set A. All point in the left side of the y. Now let's see about the next part, that is B. What is about the B? B is the argument of z minus 1 by z plus 1 equal to 2 pi by 3. What can be done for the B? The argument means angle. So if we apply that part of the circle concept, whatever I told you, and I'll take the classes on JEE advanced all this topic, so where we'll do in detail discussion. So let's see. Since it is a matter is the 2 pi by 3, so it is a smaller part. It is a smaller part. Two pi by 3, it is a smaller part. Z, this is minus 1 comma 0 to 1 comma 0, the rotation, minus 1 comma 0 to 1 comma 0. Therefore, we can write that argument of z minus 1 by z plus 1 equal to 2 pi by 3. So tan inverse y by x minus 1 minus tan inverse y by x plus 1 equal to 2 pi by 3. Okay. So if we calculate tan inverse x minus tan inverse y formula, so we are getting y by x minus 1 plus y by x plus 1 equal to by 1 plus y square by x square minus 1 equal to minus root 3. 2 tan 2 pi by 3 is minus root 3. So we can write this as, here I am changing this. We can write this here, 2y equal to x square plus y square minus 1, okay, into minus root 3. 2y, and this is coming. So this is the circle apiary, x square plus y square plus 2y by root 3 minus 1 equal to 0. So A intersection B is the center of the circle, So we can write this as center is what? 0 comma minus 1 by root 3, which is coming option B. Which is coming option B. 1 minute everybody. Let's do the next sum. In this case, z square plus z plus 1. Whenever we'll see that z square plus z plus 1, it means z equal to omega and omega square. That we have to keep in mind. So we have to get the result that n equal to summation of n equal to 1 to 15 z to the power n plus minus 1 to the power n, this value is equal to. So there are some cases when we are getting the easy sum. Easy sum means easy calculative sum. There are some cases we have to get the, but we should be ready for the worst. We have to practice in such a way that we can get the very first. Next, we are getting this. Z square plus z plus 1 equal to 0. So z equal to omega. Whenever we'll see x square plus x plus 1 equal to 0, it means omega and omega square. Okay. So we can write this as summation of n equal to 1 to 15 z to the power n plus minus 1 to the power n 1 by z to the power n. So we can write this as, this is the, it should be actually a whole square, I think, in the entrance examination. Just minute. Yes, just done that wrong. So it should be whole square. It should be whole square. So it has been some printing mistake from ourselves. So this is coming. So a square plus b square, summation of n equal to 1 to 15. So a square plus b square minus 2ab. So z to the power 2n plus 1 by z to the power 2n, and 2 into plus 2 into minus 1 whole to the power n. Okay, a square plus b square plus 2ab. Now let us apply here like this. N equal to 1 to 15. If we separate and apply the GP formula, what will happen? Let's see. N equal to 1 to 15 omega to the power 2n plus 1 by omega square to the power n, it means omega to the power 2n plus 2 into minus 1 to the power n. If we spread the summation formula, we are getting a into 1 minus r to the power n by 1 minus r plus a into 1 minus r to the power n by 1 minus r plus 2 into minus 1. It's mod. Okay. Next, we can write this as omega to the power 30. Omega cube is 1. It's omega to the power 30 is also 1. So this is coming 0. This is coming 0 minus 2. Answer is coming 2. This question came in 2022 June, 26th June. So there are some sums which is very easy. There are some sums which we need the practice on the geometry. Number of points of intersection of these two. First of all, it is the first part to circle. Second part is what? Let's see. First is the circle. The circle is the type x comma y, distance of x comma y from 4 comma 3 equal to 2. That is x minus 4 whole square plus y minus 3 whole square equal to 4. Second part is the ellipse. That is PS plus PS dashed equal to 2a, this concept. This is the best definition of the ellipse. The distance, sum of the distances from to fixed point equal to some constant number. So it is given here that PS plus PS dashed z is some x comma y, and distance of z from mod z means what? Distance of z from 0 0 and z minus 4, distance of z from 4 comma 0 equal to 2a. 2a is 2 into 3. So major axis, length of the major axis is 6. So if we draw the diagram of the ellipse, we are getting, if we draw the diagram of the ellipse, we are getting here. This is the ellipse, and this is 0 0 1 focus, and this is another focus 4 0. So their middle point 4 0. These are two focus, two foci, and the middle point center is 2 0. So this is 5 0. This is minus 1 0, such that the length of the major axis is 6. And about circle x minus 4 whole square, y minus 3. So the center of the circle is 4 comma 3. Therefore, they will cut at 2 points. By structure we can say. Let us go to the next sum. Let S equal to some z where mod of z minus 2 less than equal to 1 and z into 1 plus I plus z bar, and this is coming to be less than equal to 2. So 1 is the circle and 1 is the straight line. You have to identify by seeing this. Let mod of z minus 4i attains, it means z representing the common of the straight line and circle, and mod of z minus 4i attains the minimum and maximum values respectively at z1 and z2. So we have to get this alpha and beta by some relation. What can be done? First of all, z of 2 minus, first of all, x minus 2 whole square plus in this case y square less than equal to 1 is a circle. So I am drawing the circle first. I am drawing the circle first. I am drawing circle here. This is a circle whose center is 2 comma 0 and radius is 1. And about the line z into, about the line what is given here? Z means x plus iy. Suppose x plus iy into 1 minus I plus x minus iy into this is 1 plus I and this is 1 minus I less than equal to 2. So if we calculate same as this previous case, if we calculate this, we are getting what? X and I portion, this y, x minus y less than equal to 1. 2x minus 2y equal to 2, less than equal to 2, and other part are getting cancelled. So this is suppose the number 1 and this is suppose the number 2. Now let us solve 1 and 2. If we solve line, the line is what? Y equal to mx plus c form. So if we solve this 1 and 2, just a minute. Let us solve 1 and 2. If we solve 1 and 2, what we are getting? X minus 2 whole square plus x minus 1, y is x minus 1 whole square less than equal to 1. So 2x square minus 6x plus 4 less than equal to 0. So x minus 1 into x minus 2. So we are getting the point to be x equal to 1 and 2. So 1 is 1 and 1 is 2. If we draw the line, this is suppose A point, this is suppose B point. If x is 1, this is the obviously it is 1 comma 0, And in this case, if we put the point x equal to 2 in the line, we are getting what? If we put x equal to 2 and this 2 comma 1. And here we can see that attends PCM minimum, yes. Let z minus 4i, distance of z means what? This is set. The common point of the common region is the answer. This is the common region. All the points are z. And 4i, this is 0 comma 4. This is 0 comma 4, 4i. Now, this is the, suppose this point is P point. So this is the PA, this is the PA, this is the PB. PA distance is what? PA distance is what? We are coming here 0, 1. So 1 square plus 4 square, it means 16 plus 1, 17, root 17, and PB distance is what? Root over 13. So maximum is PA and minimum is PB. So PA is the maximum value. Now we have to get maximum, we got it. We have to get the minimum. Which point on this region is nearer to the point P? That is the target. So this is, suppose let us consider this is a D point. D point is minimum. So how to find the D? So if I just join this is a D point. If I just join this, and we have to find the point D. How to find the point D? If we can solve by, it means to get the point on any straight line, it is better method than parametric method or symmetrical method. So if we apply the symmetrical method, and P is 0, 4 and A, suppose center of the circle is C. C is 2, 0. So slope of PC slope is what? Minus 2, which is our tan theta. Therefore, we can write PC line is, we can write this as x minus 2 by cos theta equal to y minus 0 by sin theta, and at a distance 1. 1 means since 1 is the radius of the circle. Therefore, we can write, and in this case, tan theta, PC, it means tan theta. So sin theta, tan theta is negative. So sin theta positive, cos theta negative. This whole concept we need. Whatever all these things we have done in the class. So everybody, this concept is needed. Prompt cos theta is minus 1 by root 5. So we can apply this here, x minus 2 by cos theta minus 1 by root 5, and y minus 0 by sin theta, that is what is coming, 2 by root 5 equal to 1. So the point D, we can write this as 2 minus 1 by root 5, 2 by root 5. So according to the question it has been given, let minimum at Z1. So Z1 is the point D, Z2 is the point A. Now our target is 5 into mod of Z1 square plus mod of Z2 square. 5 into mod of Z1 square plus mod of Z2 square. So we can write this as Z1 means D point is what? 2 root 5 minus 1 by root 5 plus 2y by root 5. So mod of Z1 square equal to what? By 5 is I am writing. So 25 minus 4 root 5. And Z2, mod of Z2 equal to 1. Therefore, we can write this as 5 into, if we write C here, here we are seeing that 5 into mod of Z1 square plus mod of Z2 square equal to alpha plus beta root 5. So what to be done? Alpha plus beta root 5, that is 25 minus 4 root 5 plus 1 by 5. equal to coming to be 30 minus 20 root 5 equal to alpha plus root 5 beta. So alpha equal to 30 and beta equal to minus 20. Therefore, alpha plus beta equal to 10. Let us go to the next sum. One more question. Let n denote the number of solution of the equation z square plus 3 mod 3 z bar. Then the value of k equal to 0 to infinity 1 by n to the power k. K equal to 0 to infinity. So what to be done here? Z equal to x plus I by, same as this. So z bar equal to x minus I by. Therefore, what can be done here? Z square plus 3 z bar equal to 0. So x plus I y whole square 3 into x minus I y equal to 0. So x square minus y square plus I 2 x y plus 3x minus 3 I y equal to 0. So x square minus y square plus 3x equal to 0, and imaginary part y into 2x minus 3 equal to 0. So when y equal to 0, we can say x square minus y square plus 3x equal to 0. Okay. So x equal to 0 and minus 3. Therefore, when y not equal to 0, we are getting x equal to 3 by 2. And x equal to, which implies that y x equal to 3 by 2, and x square minus y square equal to minus 3x. So we are getting y equal to here plus minus 3 root 3 by 2. Therefore, there are solutions, 4 solutions, 0 0 minus 3 0 and 3 by 2 plus minus 3 root 2 by 2, 3 root 3 by 2. There are such 4 solutions. So in this case, we can write this as total solution n equal to 4. If n equal to 4, we can write this as summation of k equal to 0 to infinity 1 by 4 to the power k. So it is the infinite GP series summation. So in this infinite GP series, we can write a by 1 minus r. So this is coming 4 by 3. So option is this, 4 by 3. One more sum. Let C be the set of all complex numbers S1. So we are seeing that in 2021, 2022, one particular type is very common in number of papers. That is a set formation, set form. This is very common. So we have to practice continuously based on set forms. I'll give such papers. So what to do? S2 is this and S3. S1, S2, S3, we have to get the common to the common Z. It can be locus, it can be point of Z1, Z2, Z3. Sorry, S1, S2, S3. So what can be done here? First of all, S1 is the equation of the circle. We have to keep in mind. So we can write this as x minus 3 whole square plus y minus 2 whole square. This is S1. All the points on the circle. This is S1. That is 2 root 2 whole square. This is S1. S1. For S2, we can say all real z greater than equal to 5. It means x, all x greater than equal to 5. For S3, z minus z bar mod, it means 2iy greater than equal to 8. So mod y greater than equal to 4. And the circle and the circle I am not drawing the diagram, just I am drawing one circle, and the circle is passing through the point 5, 4. It means they have only 1 point common. So 5, 4 is the answer. So everyone, there are some lot of sums also. I showed you some different kind of sums which came in last some years. So I'll take more and more classes on complex number and all other chapters. So ready? I am leaving up to this. Bye everyone.